Hello, this is L. Nagarajan and working as an assistant professor in the Department of Electrical and Electronics Engineering in MAM School of Engineering, Trichy. So today we are going to discuss about the spectrophotometer. Okay, so we can find the name spectro. What is the name spectro? Spectrum is different wavelength, different colors. Okay, spectrum is an different wavelength of different color. Okay, you are using this spectrophotometer and identifying the presence of ions in the sample solution. The presence of ions in the sample solution. So see here, again it is operated under the principle of optoelectronic device. Okay, the wavelength is absorbed by the solution the light is absorbed by the solution at various wavelengths. Okay, various wavelengths in the sense there will be a continuous change in wavelength. That continuous change in wavelength is obtained by a mirror-like structure that we will see with a good animation. Okay, so this technique determines the unknown constituents of the solution or the concentration of the known substance in the solution. Okay, how it is done? Okay, we are passing a monochromatic light. Okay, monochromatic is nothing but a single light. Okay, single light. Okay, single light, and this monochromatic uses diffracting grating G. Okay, diffracting grating G. It is just like grated mirror, and to disperse the light from the lamp. Okay, and here you can find the light falls through the slit S0 into the spectral component. Okay, slit S1 is used to select the narrow band of spectrum, which is used to measure the absorptions of the sample in a cuvette. The light from the cuvette is given to the photodetector. It converts the light into electrical signal. Here is an diagram. Okay, so there is a light, and that light is allowed through the slit S0, and that is focused to the grating G. Okay, and from that it is allowed to the through the mirror to S1, through the slit S1 into the sample solution. Okay, into the sample solution. So this sample solution absorbs some amount of light, and the remaining light is allowed only is allowed through, that is transmitted. Okay, it is allowed through this solution, and it is detected by this photodiode, and the output from the photodiode is measured, and through the voltage, okay, through the output electrical signal, we can identify the presence of materials in the sample solution. Okay, so now we will look at the small animated video that you can able to understand very clearly.
Coming to the radiation source. So what is radiation source in UV visible spectrophotometer? Generally we are using combination of hydrogen deuterium lamp with tungsten filament lamp. So whenever we are using hydrogen deuterium lamp, then it will produce the wavelength of 200 to 375 nanometer, and when it is combined with tungsten filament lamp, then tungsten filament lamp is used to produce the wavelength 375 to 800 nanometer. But entire range of tungsten filament lamp is 350 to 7500 nanometer, but here we are using only up to 800 nanometer. So these are the radiation source which is used in UV visible spectrophotometer. Now this radiation will come to the next step and it will go to the monochromator. Monochromator is the combination of entrance slit, lens, then gratings or prism, then exit slit. So this radiation will enter into the monochromator through entrance slit, then it will go to the lens, and when this radiation, which is polychromatic radiation, will pass through the lens, then this lens will focus the radiation into the gratings, or we can use prism also. So when it will go to the grating will convert this radiation into 7 parts or 7 different colors, which is vibgyor, and then these radiations which is vibgyor goes towards the exit slit like this. So this is the complete setup of monochromator. Now coming to the complete details about monochromator. So first entrance slit will be there. So through entrance slit all the polychromatic radiation or radiations coming from the radiation source will pass through the entrance slit and it will go to the lens. And here we are using collimating lens. That lens will focus the radiation towards the gratings. And what is gratings? Gratings is an alternative of prism and it is advanced version of prism, because in the surface of gratings many small tiny prism are present. In 1 mm area there are 1200 to 1400 small grooves like structure are there, and that grooves or each grooves acts as a prism. If we are not using grating, then we have to use prism. Prism is also doing same thing. Means main work of prism or grating is that it will convert the radiation into 7 parts, which is vibgyor. Now this vibgyor will go to the exit slit, and from exit slit we can select optimum radiation, and then this radiation will go through the chopper. This is the chopper. What is the function of chopper? Chopper will convert the radiation into 2 equal parts like this. Then this radiation will go to the mirror. Then these mirrors will reflect the radiation into the next level. In next level, there will be sample and there will be reference. Okay. So one radiation will pass through the reference and one radiation will pass through the sample. Okay. So for sample or reference holding, here we have to use cuvette, and that cuvette is made up of quartz. If we are using cuvette of quartz, then it will cover the entire range of UV visible, because quartz will not absorb UV light as well as it will not absorb visible light. But if we are using the cuvette of glass, then it can be used only in visible range, because glass will absorb the UV light. Now this radiation will pass through the cuvette and it will go to the next level. After going to the next level, this radiation will go to the detector, and there are 2 detectors because it is double beam UV spectrophotometer. So first reference one will go to the D1 detector 1, and the sample radiation will go to the detector 2. So there are 3 types of detectors used in UV visible spectrophotometer. First one is photomultiplier tube. In short, it is known as PMT. So what is photomultiplier tube? So when radiation which is passed through sample or reference, it will come to the detector. If we are using photomultiplier tube, then radiation contains photon, and that photon will go to the photomultiplier tube. Then it will be converted in the form of electrons, and that electrons will go to the dynode, because series of dynodes are present in photomultiplier tube, and the function of dynode is that it will multiply the electrons. So those electrons will be multiplied, and ultimately multiplication of electrons takes place. From 1 photon, approximate 10 to the power 6 electrons can be generated. Now coming to the second type of detector, which is used in UV visible spectrophotometer. So that is photodiode array. It is also known as PDA detector. So how PDA works? In PDA detector or in photodiode array, there are various diodes are present, and these diodes will convert electromagnetic radiation or UV visible radiation into the form of electrical signal. And this PDA detector covers entire range of UV visible, that is 200 to 800 nanometer, and generally this PDA detector is used in HPLC. Now coming to the third detector which is used in UV visible spectroscopy is charged coupled detector. It is also known as CCD. So in CCD, silicon surface will be there, and when radiation will come to this silicon surface, photons will attack on the surface of silicon. Then these photons will be converted in the form of digital signal by using CCD or charged coupled detector. So these are various detectors which can be used in UV visible spectrophotometer. So now in next step, this detector will pass the signal towards the amplifier. So amplifier will amplify the signal, and this amplified signal will go to the recorder, and ultimately recorder will record the signal in the form of UV visible spectra. Spectra will be like this. So this is the working and the instrumentation of double.
So now from this animated video, you might have understand that how the spectrophotometer is working. And my sincere thanks to Pushender sir class, Dr. Pushender sir class. Thank you. We will see in the next class.